Okay, let's start. Okay, so simultaneous equations. Let's just run through a bit on what simultaneous equations is. You would have probably covered a bit during Head Start already if you were there for Head Start. So simultaneous equations means that we have two equations at the same time. Simultaneous normally means at the same time. Okay, so during Head Start we will learn elimination and substitution. If you have not, then you can just watch this and learn on the go. Okay. So let's just run through a bit on what elimination and substitution mean. Elimination means you cancel out something, right? Substitution means if you play football or you play soccer, whichever one you call it, right? Um, Substitution means that you replace something with something else. Or in the context of sports, you replace a player with something else. So it's the same idea. Okay. So let's recap a bit about linear equations. Okay, so linear equations is basically just an equation that looks a bit like this. Okay. Next time we'll learn something called quadratic equations. The only difference between quadratic equations and linear equations is that quadratic equations will look like this. Linear equations will just be this, right? So quadratic equations have this power 2, and linear equations is just x, right? No powers, no nothing, right? The moment it's x squared or x cubed, it's not called a linear equation anymore. Okay, can? Okay, so now that we have two equations, this is what we call simultaneous equations. Simultaneous equations, two equations at the same time. Okay, now when we solve for a simultaneous equations, right, it has to satisfy both equations. What does satisfy both equations mean? That means if I put in the x, I should get out a good y, or at least this equation will make sense when I plug in the x and the y. Okay, if I plug in that same x and y, it should make sense here. Okay, can? So let's run through a bit about understanding simultaneous equations. So the concept of simultaneous equations, right? If you understand graphs, which you will have learned in Sec 1, where you've learned all your like y equals mx plus c and stuff like that. If you learn your graphs, right, different graphs have different shapes, right? What happens when you solve for simultaneous equations is that two graphs of maybe different like orientation will intersect at some point maybe. The intersection point is what you get when you solve for a simultaneous equation. Okay, can? Okay, can. So let's run through the methods. So the methods include elimination, substitution, and a graphical method. Okay, we won't run through too much of this whole page. I think the main part about simultaneous equation is understanding the application first, then understanding how you do it, and then you understand the application. Okay, so method to do it is more important first. Okay, so let's run through the first method for solving simultaneous equations. Okay, the first method is elimination. So let's look at example one. So using elimination method, solve the simultaneous equations. So what you will have learned last time is that you can solve an equation like this one, right? So x plus 5 equals 6. What can you do, right? X will be 6 minus 5. Why? Because you can just minus 5 on both sides, right? So for those who aren't sure what that means, remember x here plus 5 equals to 6 on this side, right? To get just x, how much does x weigh or what is x worth? You need to minus 5 on both sides to make sure that the scales are balanced, and then you get x equals to 1. Okay, so this one you have learned before in Sec 1. But again, we can only do this kind of thing when we have just one variable. What does one variable mean? That means we only have the x here. Do you notice these equations have both x and y? Right? So it's very difficult to solve them. So what we do in simultaneous equation is we try and make sure we can get rid of one of those variables. And those methods, to get rid of the one variable is called elimination and substitution. Okay, we'll see how it gets rid of the variable later, but let's just run through this. So 2x minus y equals 6 and 3y plus 4x equals 12. Okay, so what we're gonna do is first of all we're gonna label the equation 1 and 2. So what does that look like? That will look something like this. 2x minus y equals 6, 3y plus 4x equals 12. And all we're gonna do is just draw a line. This one is 1, right? You can do it like that. my preference is I just 1 and then I do a circle, and then 2, and then I draw a circle. Okay, so as long as you label it 1 or 2, you'll be fine. Okay, there is no need to have it um exactly like must be in bracket. That one is the least of our concerns. Okay, as long as you have both equations that you can show, it's fine. Okay, then the next step is multiply each equation by a number to obtain the same coefficient for one of the variables. Okay, regardless of the sign. Okay, so what does this mean? A bit confusing, right? Okay, so let's think about this. Elimination means what? We need to cancel out one of the x's or y's. Okay, can. So in this moment, let's look at the x here, 2x and 4x. Okay, let's just think for a moment. Do you think we can cancel them out somehow? 2x and 4x. 2x cannot cancel out 4x, right? 4x also cannot cancel out 2x. Either way, it doesn't work. Can y and y, 3y and y cancel out? Not really, right? So what we have to do is we have to make sure that they can cancel out somehow, right? So how do we make sure they cancel out somehow? Make one of the numbers uh, make the 2x maybe into 4x. Okay, you'll see how this applies in a bit, but let's just go on. So equation 1 times 2 will look something like this. It will become, right? So this I have to times 2, this I will also have to times 2. Okay, so 4x minus 2y equals to 12. Okay, now let's think about this. Okay, we can now call this maybe equation 3. Can this 4x cancel out 4x? Yes, right? Yeah, okay, so what do I mean by cancel out? So let's now do equation 2 minus equation 3. Okay, so let's do equation 2 minus equation 3. The way I like to think about it is left side minus left side, right side minus right side. What does that mean? This is the left side of equation 2. This is the left side of equation 3. Right, so the left side of equation 2 minus the left side of equation 3 equals to the right side of equation 2 minus the right side of equation 3. Okay, so this will look something like y plus 4x. Okay, and then, oh, sorry, I think I am missing a 3 somewhere. So there should be a 3 here. Okay. So 3y plus 4x minus 4x minus 2y, right? Whether you have the brackets or not, for this one, it doesn't really matter. So equals to 12 minus 12, right? So let me just tell you again what's left side, what's right side. So left side of equation 2 here, right? Minus right side of equation 3 here equals to left side, right side of equation 2 minus right side of equation 3. Okay, can? Or another way you can think about this is 3y plus 4x equals 12, right? Right, so that's how you get this 12 here. This 4x minus 2y is equals to this 12, right? Yeah. So you're minusing 12. Okay. But anyway, what happens here? When you work this out, you realize that this plus 4x and minus 4x kind of cancel out, right? Do you agree? So what you'll be left with is eventually 5y equals to 0. Yeah? So why do we need these to be the same? So that they can eventually cancel out. And what do we have now? We have one variable. Okay, whenever you have just one variable, you can generally solve it. 5y equals 0, then we can work out y by dividing by 5 on both sides, giving y equals 0. Okay, then now that we have y equals 0, is that the final answer? Okay, one thing you realize is that we still have two variables in this equation. So how many things do we have to solve for? So we have x and y, right? Can we just solve for y? No, we need to solve for both x and y. Okay, so what we do is sub back in the y equals 0. So sub y equals 0 into 1. So where's 1? 1 is 2x minus y equals 6, right? So 2x minus y, we've already replaced the y with the 0, right? So 2x minus 0 equals 6. And then 2x equals to 6. We should know how to solve this. X equals to 3. Okay, then finally, we have both answers, which is x equals to 3 and y equals to 0.